press a button every single day, and just like that, your computer springs to life. It feels instant, like magic, right? But it's not. It's actually a super high-speed chain reaction that all happens in just a few seconds. So today, we're going to pull back the curtain and show you exactly what's going on in that whirlwind journey from a blank screen to a ready desktop. Okay, let's get right into it.
You know exactly what I'm talking about, right? That little pause, that bit of silence between hitting the power button and seeing that Apple or Windows logo pop up. Well, that isn't wasted time. Nope, that's where everything happens. So what's really going on in that quiet moment? Let's find out. Okay, so it all kicks off with electricity. But here's the thing, you can't just zap your computer with a raw jolt of power. Its components are so delicate, they need a perfectly clean and stable current before they even think about waking up. It really is the difference between a gentle nudge and a loud, shocking alarm clock. So get this, when you press that power button, you're not actually turning the computer on. You're really just sending a little request to the power supply unit, or PSU, basically giving it a nudge to wake up. The PSU then does a super fast self-check to make sure the power it's about to send is stable and clean. And only when it's absolutely sure, it sends the final all-clear signal to the motherboard. And that signal, that's the powered good signal. Think of it as the starting pistol for the entire boot process. Before that signal hits, the motherboard is smart enough to hold the CPU, the brain of the computer, in a reset state, just to protect it. But the second that signal arrives, the race is officially on. All right, the starting pistol has fired. The CPU springs to life. But here's the wild part. It has total amnesia. Its memory is a completely blank slate. There's absolutely nothing there. So with no memory and zero instructions, what's the very first thing it does? No, really, think about that. Waking up with zero memories. You wouldn't know who you are, where to go, or what to do. That's the CPU at this moment. It doesn't have an operating system, no software, nothing. And yet, it has to kickstart the entire show. How? Well, its designers gave it one single, unchangeable, hardwired instruction to follow. That one instruction, it lives at a special hard-coded address called the reset vector. This isn't software. It's physically burned into the CPU's silicon. The treasure map analogy here is perfect. The CPU doesn't get the whole map. It just knows the exact location of the very first clue. And where is that first clue? It's at this very specific address, way up at the top of the CPU's memory map. And this isn't random. It's built this way on purpose so that every single time it wakes up from that state of amnesia, the CPU instinctively knows exactly where to look first. So what amazing, complex piece of code does it find there? You'd be surprised. It's just one simple command, jump. That's it. It's an order to immediately jump to a different location where the real startup program is waiting. So that's right. The very first thought your super powerful computer has is to immediately go look somewhere else. So that jump instruction, it's basically a perfect handoff. Control gets passed to the system's firmware. Now, a good way to think about the firmware is as the team captain. Its first job is to run around, wake up all the other hardware, the memory, the hard drive, the keyboard, and make sure everyone is ready to play. Now, for a long time, this firmware was the old school BIOS, the one with the blue text-only screens. But modern computers, they use something called UEFI, and man, it is a huge upgrade. You get a nice graphical interface with mouse support, it boots way faster, it can handle gigantic hard drives, and most importantly, it has this great security feature called Secure Boot that helps stop malware from messing with your startup. Okay, so the first thing this new team captain does is run what's called a power-on self-test, or POST for short. And the pre-flight checklist analogy here is spot on. Before a plane takes off, the pilot has to check that everything is working. The POST does the exact same thing for your computer. So what's on this checklist? Well, the POST does a quick roll call of all the essential gear, the CPU, the RAM, your drives, the video card, even your keyboard. If it finds a big problem, like your memory is faulty, the whole show stops right there. You might remember older computers making these weird beeping sounds. Yeah, that was the POST telling you something was wrong. All right, pre-flight check is done, all the hardware is accounted for and working. Now the firmware has one last super important job to do. Find the pilot, which is the operating system, and hand over the controls for the main flight. To do that, it starts looking through your drives for a tiny little program called a bootloader. Now its job is massive.
find the core of your operating system, what's called the kernel, and get it loaded into the computer's memory. It's basically the key that starts the main engine.
And this is the big moment. This is the handoff. The low-level firmware, which deals directly with the hardware, is about to pass full control to the high-level software, your operating system. It's like a perfect baton pass in a relay race. The firmware has done its part. Now it's passing the baton to the OS to finish the race. Okay, the baton has been passed. The operating system kernel is in memory, and it takes total control. And this, everyone, is the final sprint, the lightning-fast dash that gets you from a black screen all the way to your login. And a ton happens here, really, really fast. First, the kernel loads all the drivers. Think of them as translators for your specific hardware. Then, it fires up all the essential background services that keep things running. And finally, boom, it launches the process that draws that login screen you see every day. So let's just step back for a second and look at that whole journey. It all started with a simple, stable power signal. That woke up a CPU with Amnesia, which followed a hard-coded treasure map to find the firmware. The firmware then did a hardware checkup, found the bootloader, and passed the baton to the operating system. The operating system then loads its drivers and services, and finally puts the login screen in front of you. And the craziest part of all? This entire, incredibly complex chain reaction, from a dead machine to a ready-to-go login screen, happens on most modern computers in under 10 seconds. I mean, that is just an absolutely mind-blowing feat of engineering. You know, this whole process is such a perfect example of the hidden complexity we just take for granted every single day. So the next time you power on your machine and you're waiting through those few seconds of darkness, you'll know it's not empty. It's a high-speed, perfectly choreographed dance, bringing everything to life. So I gotta ask, the next time you press that power button, are you gonna see it the same way?